A recap of last session, we had the Earth coordinates, latitude and longitude explained. Celestial coordinates as declination and right ascension was also explained. Horizon coordinates, azimuth and altitude of heavenly body was also talked about. The view of the celestial sphere as seen by an observer was shown. In continuation of what we have done so far in the last class, as I had indicated earlier, since these are the two basic fundamental sessions that is going on, I will deliberately go slow so that the basics and fundas are very clear in our mind before we proceed for higher definitions and problem solving in the case of celestial navigation. So in continuation of that, we will see now how the heavenly bodies move with reference to the earth, and we will also see how an observer will view the heavenly bodies from different latitudes. Shall we proceed ahead? Any doubts in the last session? Okay. On the celestial sphere, we come across the heavenly bodies going through a diurnal circle. What's a diurnal circle? What does the word diurnal mean? Anybody? Can anyone answer what is the meaning of the word diurnal?
A cycle in a day, sir?
Any activity that takes place in a day or a day's cycle is called as a diurnal activity. And in the case of the celestial sphere, the heavenly bodies, their activity over a day follows what is called as a diurnal circle. Each celestial object circles the observer each day. So an heavenly body, which is, if this is the rational horizon, which we have been seeing often in the previous slides, heavenly body rises on the eastern side and goes and sets on the western side and goes below the horizon for the remaining part of the day and comes back next day again. So observer sees each part of this circle during the daytime. And when the body is above your horizon, this is your horizon. When the body is above the horizon, you see it rising on the eastern side, go over and then set on the western side. And the observer sees the full diurnal circle if the body is somewhere in this area. We will discuss about this a little later. What do you mean by this circumpolar, etc. Right. Now, how does the observer see it? This is the reality, what is there. But when you are standing on the surface of the earth, you don't see this part of the earth. You don't see this part of the celestial sphere. What you see is only this horizon around you and the entire sky above you. So in all practical purposes, it's better that we see this from the observer's frame of reference. How do we see it in the observer's frame of reference? Let us rotate the picture the other way. Now, you see, this is your rational horizon. You don't see this part of the celestial sphere or the earth anytime at all. What you see is the horizon around you. You are in the center of that horizon and the sky above you. The heavenly bodies start rising in the east and setting in the west. Those heavenly bodies which are here above, they do not set at all because they are always above the horizon. And the stars are always visible. Those heavenly bodies here are always visible, which are above the horizon. And these heavenly bodies which are below the horizon, you never see them. If this is the celestial equator, I had explained to you last time that depending upon the latitude of the observer, the celestial equator is inclined by an angle, and this represents your celestial equator. Any body on the celestial equator will be visible to you 12 hours during it when it is above the horizon, and 12 hours you will not see it below the horizon. Now, if this is the situation, any star that is here, you will never be able to see below your horizon. How does the observer see it? All diurnal circles are always parallel to the celestial equator. If this is your celestial equator, you can see the diurnal circle, that is the circle over which the heavenly bodies pass, are always parallel to the celestial equator. In addition to that, all these diurnal circles are all having the circle with the pole as the center. The stars rise and set at the same angle as the celestial equator from the horizon. If this is the angle that the celestial equator is making with the horizon, which is nothing but 90 minus your latitude. So the celestial equator is inclined to your horizon by an angle 90 minus latitude, and all heavenly bodies rise at the same angle, and they all pass parallel to the celestial equator throughout. When they reach the western point of your horizon, they set. You don't see the stars or heavenly bodies after that. Stars rise parallel to the celestial equator, and stars set parallel to the celestial equator. Now, from the rational horizon of the observer, each star travels a diurnal circle. So it goes, and for example, the star Vega, which is always available in the northern hemisphere, for this person who is somewhere in the northern latitudes, Vega's diurnal circle will be up for 19 hours. You'll be able to see the star Vega if you can see it. If the sun is not there, you can see the star. If the sun is having a northerly declination, it will follow this diurnal circle. And this will be up for about 15 hours. Why it is 15 hours? Because the sun is in a northern hemisphere. It is having a northern declination, and the celestial equator is supposed to be passing from here to here. I have not drawn the celestial equator here, but celestial equator will be like this, as we have seen in the earlier slides. For a star which is on the southern hemisphere, Antares, which is a star which is generally in the southern hemisphere, this will rise again on the eastern side, move over and set on the western side. It will be available only for a period of 8 hours. So as we can see, depending upon the declination of that heavenly body, it will be available for a longer period or for a shorter period. All the same, they all follow a circular path, and that circular path is always parallel to the celestial equator. Is it so far clear?
Yes, sir.
Righto? That's what. All paths are parallel to celestial equator. Now, we can see that if this is your celestial sphere, you are in the center. The earth is in the center. You are on the surface of the earth. You can see various heavenly bodies on the celestial sphere. All these stars are actually at different distances where they appear to be located on the celestial sphere. Why? We see as if they are stuck onto the celestial sphere because our lack of depth perception, when we look into the space, creates the illusion that Earth is surrounded by the celestial sphere. In reality, stars that appear very close together in our sky may actually lie at very, very different distances. This is in reality what is there. You see stars at different distances actually, but as if you see as if they are all stuck on one dome, which is your celestial sphere. A recapitulation of what we have seen earlier. If this is your Earth, Earth is rotating from west to east along the equator. Projection of equator is your celestial equator. These are all your declination circles. This is the north pole of the Earth. This is the south pole of the Earth. Extension of that to infinity leads to north celestial pole and south celestial pole. Remember, the celestial poles and celestial equator are points on the celestial sphere and not on the Earth. These are the definitions you have seen earlier. What is zenith? Zenith is the sky above you, an infinite distance point right on top of your head at any place on the Earth is called as the zenith. The one opposite below the horizon on the other side of the Earth, extension down below, will be your nadir. Horizon is that circle which is 90 degrees from your zenith in all directions. What is the horizon? Horizon basically your field of view. When you stand on the bridge of your ship, what you see around you in an open sea is a circle of water, and where the earth and the sky, where the water line and the sky touches, looks like touching, that circle is your horizon. And that horizon details we will discuss in the subsequent classes as to what are the different types of horizon. Basically, for the purpose of our mathematical calculations, we take the rational horizon, which is the horizon with the center of the celestial sphere or the center of the earth as the center of that horizon. That is your rational horizon. And meridian is that semi-great circle joining from the north point to the south point. Transit is the passage of a heavenly body over your horizon from eastern sky to the western sky. That is what is the transit of a heavenly body. In the horizon coordinate system, what did we see? Azimuth and altitude. If there is a star here, I hope you can see the laser pointer. If this is the star here, the star has an altitude of 60 degrees from the horizon. From the horizon 60 degrees, and it is from the north measured towards east in the southeast direction. So direction of the star is southeast and altitude is 60 degrees. So azimuth is normally measured 0 to 360 degrees around the horizon from north towards east. So north is 000, east is 090, and south is 180, west is 270, and back to north, which is 300, 360 or 000. Altitude from the horizon to zenith is always 90 degrees from anywhere. From anywhere to zenith, from the horizon is 90 degrees, or from zenith to the horizon anywhere is 90 degrees. This is your horizon coordinate system. We do use this because altitude we measure using our sextant, and azimuth we can check using our azimuth circle on your gyro repeater or a magnetic repeater, whichever you have. The path of the sun, which you had explained earlier, is called as the ecliptic. The apparent path of the sun is called as ecliptic. And the various points of the ecliptic crossing the celestial equator is defined as the first point of Aries or the vernal equinox. Vernal equinox is also called as the spring equinox, which normally occurs on March 21st. It is a point of intersection of the celestial equator and the ecliptic. In the month of March, 21st of March is your spring equinox. Recently, we did cross the spring equinox where the sun's declination here would be 0 degrees. At the vernal equinox, the length of day will be equal to the length of night, which will be 12 hours. On that day, everywhere on the earth, you will have 12 hours of daylight and 12 hours of nighttime. As the sun moves northwards, it reaches a maximum declination of 23.5 degrees north, where it is called as summer solstice on June 21st. The sun is at the highest point in the sky. After that, it moves to fall equinox or autumnal equinox on September 21st on the other side, where again the declination of the sun would be 0 because the ecliptic and the equinoctial are intersecting there. Subsequently, it goes to the southernmost declination on December 21, where you have the winter solstice, where you have winter in the northern hemisphere, and then back again to the vernal equinox. That's why you find that when the sun is having most southerly declination of 23.5 degrees south, it is winter in the northern hemisphere. It's called as a winter solstice. And at this point of time, when the sun is southernmost, the southern hemisphere will have maximum sunlight. That is why does Indian cricket team go and play invariably on December 25th in Australia? Because it is summer there. On the Boxing Day, you always have a cricket test match. It's summer during this period of time, they go and play. We go and play in England in the month of March. Why? You have a better season there to play in England during that time. Right. Is that clear? Okay. Vernal equinox, sun appears on March 21st. At the vernal equinox, the right ascension is 0 degrees. Why? Because it is intersecting with the celestial equator. The declination of the sun is 0 at this time. As it moves on the ecliptic, the right ascension keeps increasing to the point where it reaches here the right ascension is summer solstice is 6 hours. Subsequently, when the sun goes to the autumnal equinox, the right ascension is 12 hours. You can see from here it has gone to 6 here and another 6 hours to reach there. When the sun goes to the winter solstice, it has traveled another 6 hours, so it is 18 hours is your winter solstice. And when it comes back to vernal equinox, again the right ascension is 0. So right ascension is always given in terms of hours, minutes and seconds and measured only eastward as the movement of the sun is taken into account. The declination of the sun changes from 0 to 23.5 degrees north to 0 to 23.5 degrees south and back to 0. So the variation of your sun's declination is 23.5 degrees north to 23.5 degrees south over a period of 1 full year. Now, with that explanation of the declination and the right ascension, we can define the position of any heavenly body on the celestial sphere. For example, Vega is a star. If it is in this place, the declination of the star is north of the celestial equator and it is plus 3844. As I told you, in some American books, they don't call it north, they call it plus. If it is southerly declination, they call it minus. So Vega has got a northerly declination of 38 degrees 44 minutes and its position is here. So the right ascension is measured from here all along the equinoctial and comes around like this to this. That's what is indicated here. This is the meridian passing through the vernal equinox and measured eastward all along and comes back here. So the right ascension is 18 hours 35.2 minutes. So any heavenly body can be defined by its declination and the right ascension. Okay. This is what is explained here. Declination of the star Vega is 3844 north of the celestial equator and the right ascension can be as an angle, it is 279 degrees from here to here. As a time, it is 18 hours 35 minutes after the spring equinox or the vernal equinox. So the same time can be still in angle also as 279 degrees, 279 degrees measured eastwards. Now, comparison between the Earth and the celestial sphere, we have said already, latitude and longitude on the Earth indicates your position. On the celestial sphere, the declination and the right ascension of the heavenly body indicates its position. So you can compare them to each. Latitude is something like declination and longitude is something like your right ascension. So if you can have the declination and the right ascension of a body at a time, I can project it down on the Earth to find out where that body's position is on the Earth. If you can recollect and go back to the first slide in the last session, the difference between terrestrial navigation and celestial navigation. In terrestrial navigation, we have the position of the terrestrial body available on the chart. Whereas in celestial navigation, we do not have the position of the celestial body on the chart, but we can get its position, declination, right ascension. If I can project it down onto the chart, that is called as your geographical position. And from there, we can identify ship's position. Now, when we are discussing all along the term called as right ascension, which is something similar to the longitude which we say, for academic interest, heavenly bodies are given the nomenclature of declination and right ascension. But in reality, when we start solving the celestial navigation problems, we come across another term called as the R angle or the sidereal R angle, which we have to understand. What is that R angle or sidereal R angle? We'll see it now. On the celestial sphere, we have already seen if this is your North Pole, down below is your South Pole, and this represents your celestial equator. And if this is the meridian passing through the vernal equinox, can you see the pointer passing through? This is the meridian passing through the vernal equinox or the first point of Aries. Now, we said the declination angle is the angle north or south of the equator. Now we have a star position here in this place. The star's position is here means the declination of the star is so much north of the equator. This arc of the meridian passing through that star is your declination. So this arc of the meridian passing through that heavenly body, angle measured at the center of the celestial sphere, is your declination angle. Now, from the vernal equinox, measured eastwards, that is what is your right ascension. This right ascension is normally given in terms of hours, minutes, and seconds. So what is this? This is this easterly arc given in terms of hours, minutes, and seconds. Or in degrees, this is the angle subtended by this major arc of this celestial equator. And what we normally use in all our calculations of celestial problems is a term called the sidereal hour angle. Sidereal hour angle is basically the angle measured westwards from first point of Aries to the meridian passing through that heavenly body. So this part of the celestial equator measured westerly from the first point of Aries to the meridian passing through that heavenly body is called as the sidereal hour angle. This angle or this arc of the celestial equator between the first point of Aries and the meridian passing through that heavenly body is called as the sidereal hour angle, or in other words, it is the angle measured at the pole between the meridian passing through the first point of Aries and the meridian passing through that heavenly body. This angle at the pole is what is called as the sidereal hour angle. Anything to do with first point of Aries is called as sidereal. Remember that. Throughout our language in the celestial navigation classes, the minute the word sidereal is used, which means the reference point is the first point of Aries or the vernal equinox. So angle measured at the pole between the meridian passing through the vernal equinox or the first point of Aries to the meridian passing through that heavenly body is your sidereal hour angle. So from this we can understand, if right ascension is measured eastwards so much, the sidereal hour angle is measured westwards. So if the whole thing is 360 degrees, sidereal hour angle is nothing but 360 minus right ascension. Yes? Any doubt on that?
Awesome.
So sidereal hour angle is basically 360 degrees minus the right ascension. Sidereal hour angle is the terminology which we normally use for all our calculations. Now in this case, what is this hour angle which you are talking about? Hour angle is a generic term for any measurement of angle at the pole between any two reference meridians. For example, the hour angle between the first point of meridian passing through the first point of Aries and the meridian point passing through the star is called as the sidereal hour angle. Supposing I have an observer. The observer is, let us say, in this longitude or in this meridian, meridian passing through the observer is here. Now, when it is the observer is here, the angle measured at the pole between the meridian passing through the observer to the meridian passing through the heavenly body. This angle, this is called as LHA. Local hour angle. When I say local, anything to do with observer's position is called as local. So this angle is your LHA or local hour angle. Now, if I can position the Greenwich, if this is the meridian passing through the Greenwich, the angle at the pole between the meridian passing through the Greenwich to the meridian passing through that heavenly body, this angle is called as the GHA or the Greenwich hour angle. So what do we see? Hour angle is basically the angle at the pole between two meridians. Which are the two meridians? Reference meridian, if it is through first point of Aries, it is sidereal. If it is from Greenwich, it is Greenwich. If it is from observer, it is local. So sidereal hour angle, meridian from vernal equinox to star. Greenwich hour angle, meridian through Greenwich to star. Local hour angle, meridian through observer to star. So that is your GHA, LHA and SHA. Now knowing that the entire thing is a globe and pole is the center of all these angles, we can understand this GHA, LHA and SHA by drawing a circle with pole as the center. Let us understand that in that manner. See this diagram. In this diagram, pole is in the center. This is the meridian passing through the first point of Aries. Can you all see the pointer?
Yes, sir.
Okay. This is the meridian passing through the first point of Aries. This is the meridian passing through the Greenwich. This is the meridian passing through that heavenly body. It could be a star, it could be a planet, it could be sun, anything. And this is the meridian passing through the observer. So as we had said earlier, what is SHA? SHA is the angle at the pole measured from the meridian passing through the first point of Aries to the meridian passing through that heavenly body. So this angle, as indicated in green, is your sidereal hour angle. So by drawing with pole as the center, and the meridians are always emanating from the pole, isn't it? So this is your SHA. Now from Greenwich, angle measured at the pole, measured westwards to the meridian passing to the heavenly body is your GHA. And from the observer position, angle measured at the pole from the observer's meridian to the meridian passing to the heavenly body is your LHA. So LHA, SHA and GHA, these are the terminologies, these are the quantities which we always use in all our mathematical calculations involving celestial navigation. Is this understood? Because this is what we are going to use hereafter throughout in all our calculations. Right ascension is the term that is used to describe the heavenly body in the celestial sphere. It's for academic interest. But all practical purposes, we use these terms for our calculations. So the two coordinates that we use for the heavenly body in all our calculations would be, one is declination, whether it is north or south of the equator, and the hour angle, whether it is SHA, GHA or LHA, which we'll be using. Is it clear till now? Can we proceed?
So clockwise first word is right.
You are not audible. Can you just be a little more clearer?
So measuring from the clockwise direction.
I'm still not able to make out what.
The SHA is measured in this diagram, the SHA is measured clockwise, sir.
Please do not confuse with clockwise or anti-clockwise, because the minute you go down to South Pole, it will be the other way around. Hence, always I have been insisting, and I never use the word clockwise or anti-clockwise. I use the word westward. Angle measured westwards from the meridian from vernal equinox or the first point of Aries to that heavenly body. Angle measured westwards from the local observer. Angle measured westwards from the Greenwich meridian. So it's always a westward measuring angle. Just remember that at the pole. Clear? Because if you use clockwise and anti-clockwise, there is a possibility that you may get confused, because if this is a north celestial pole, and if you are in southern hemisphere, if you start using the south celestial pole, it will be the other way around. Whereas it is better to use the cardinal directions of westerly or easterly. Clear? Who was asking that doubt? Is it clear to him?
Yes.
I think there is some disturbance in your mic. Can you just keep the mic away, or you can speak through the headphone if it is possible?
Yes, sir.
Or garbled at times. Yeah.
Or you can type the question in your chat. We will read it to the.
Yeah, that might be better. Okay. Now let us understand how the local skies are. We have seen it also earlier. Now, for a person who is in the North Pole, you can see on the left side diagram, this is the actual situation. That is, this is the Earth. Person is standing on the North Pole. For a person on the North Pole, this is your celestial equator, and that also happens to be the celestial horizon or rational horizon. Right above the North Pole is the zenith, and it coincides with the North Celestial Pole also. So you can imagine a person standing on the North Pole of the Earth. Right above his head is the zenith, and right above his head is also the North Celestial Pole. And what he sees around him is your rational horizon, and that rational horizon happens to be nothing but your celestial equator. Why is this so? Because we all know from zenith to horizon is 90 degrees anywhere. For a person in the North Pole, zenith is the North Pole. 90 degrees from North Pole is nothing but the equator. So in both cases, North Pole to equator is 90 degrees, zenith to horizon is 90 degrees. So for a person on the North Pole, the horizon represents the equator, celestial equator or the equinoctial, and the zenith represents the North Pole. Now for this person, every heavenly body will be moving around in a circular path in this fashion. Why? You can imagine if you are standing on the North Pole, the Earth is rotating from west to east, which means for a person standing on the North Pole, if you slightly jump up, you will look as if the Earth is rotating anti-clockwise down below. All heavenly bodies will be moving from east to west, which will be moving in a clockwise direction. So all heavenly bodies moving in a clockwise circle like this, and celestial equator is here. So for a person who is on the North Pole, if the celestial equator is here, if a heavenly body has a declination 0 degrees, which means it is on the equator, so it will be just going around and around in a circle on the horizon itself. For a heavenly body which is having declination 0, will be moving around the same circle on the horizon. If the heavenly body has got a 90 degrees declination, it will remain on top, on the zenith itself. A heavenly body with 30 degrees declination will be moving around a circular path like this. Heavenly body with declination 60 degrees will be moving in a circular path like this. All these circles are having North Pole as the center of that circle. And their path, as I told you earlier, is all parallel to the equator. All heavenly bodies travel parallel to the equator, and their path is circular, and the center of the circle is nothing but the pole. This is what is in reality. But what you see as an observer is this diagram. As an observer, you see the horizon around you, and that horizon is your celestial equator, and the heavenly bodies are moving in a circle all around. At what height are these objects moving around? This is a representative of the declination. A 90 degree star declination will be right on top. A 0 degree star will be having 0 degrees altitude. A 30 degree declination will be at an altitude of 30 degrees. That's what it says. Any star circles the sky daily at an altitude equal to its declination. So for a person on the North Pole, if you see a heavenly body, that heavenly body will be moving around in a circular path with pole as the center, and the altitude of that star will be equal to its declination. Is it clear? Right. This is as far as a person in the North Pole is concerned. Let us move further. Now, see what happens if the person is at the equator. Now, actual scenario is here. This is the Earth. This is the equator. And you are standing on the equator. For a person standing on the equator, this is the zenith. If the person is standing on the equator, this is the zenith. Zenith to the horizon is 90 degrees always. So this is his horizon. If this is his horizon, this horizon axis is aligned with the North Celestial Pole. So which means the horizon circle which is having is aligned to its North Celestial Pole, and this is your equator. You can see that the celestial equator is exactly on the east point and west point of the observer, and they all have an equal semicircle above and below. Above the horizon, below the horizon, equal semicircle. So for a person on the equator, celestial equator moves from the east point of the observer to the west point of the observer. All heavenly bodies, if it is having zero declination, it will be exactly on the celestial equator, go like this. So if he is on the equator and that heavenly body has got zero declination, it will come right on top of his head and then go and set here. So for the person at the equator, if the body has got 30 degrees declination, it will rise here and will set here. It won't come on top of his head. It will be remaining north of him. A body with 60-degree declination will still be here. It won't come on his zenith. So you can see that only body which will come on the zenith will be a body whose declination is the same as the observer. Observer is at equator, zero declination will only come on top of the zenith. Now this is in reality. But what you actually see is the second diagram. This is the horizon that you see diagram. So this is your horizon diagram. On the horizon diagram, the person is standing on the equator. This is your north-south axis. This extended means North Pole and the South Pole. And the equator, celestial equator, passes right over his head. Body rises east, sets and goes below the horizon. You can't see it. So a body with zero declination only will come on top of the zenith. A body with 30 degrees declination is going to rise here. It will reach maximum on his meridian here. So it is not on top of his head. It is north of him. And set here. Similarly, 60-degree declination will be here. On similar lines, body with southerly declination will rise here and set south of him. It will be remaining south of him. South 60 degrees will rise here and set here. So that's what happens for an observer at the equator. Now, at any other latitude, at 40 degrees north latitude, what happens? This is the Earth. This is your 40 degrees north latitude. Equator is here. So this angle is 40 degrees. For him, zenith is here. If this is the zenith, this is your angle of latitude. All heavenly bodies will always travel parallel to equator. We saw that the celestial equator is inclined to him. This is your celestial equator. So all heavenly bodies travel parallel to the equator. Only when it is reaching a point where you can see here, this declination of this body is 60 degrees. Your latitude is 40 degrees. This body does not go below the horizon at all. It remains above the horizon, which is what is your circumpolar body. On the opposite side, in the southern hemisphere, with 60 degrees south declination, it doesn't come above the horizon at all. You can't see this body at all. Mind you, every body keeps moving in a circular path with the pole as the center and travels parallel to equator. The same thing with the horizon. Same thing can be seen. We have seen this diagram earlier. With the observer here at 40 degrees north latitude, the celestial equator is inclined. Inclined by how much? We saw it earlier. This angle is 90 minus latitude. All circles are parallel to the equator. And these circles all have pole as the center. A body with 60 degrees north declination will not go below the horizon. So it remains on top throughout, called as your circumpolar body. Now, similar in the southern latitude, if the observer is in south latitude, this is going to be the zenith, and the entire horizon is tilted like this. What we saw in the north latitude, it is just the opposite of it in southern latitude. You see that the celestial equator is now inclined in this direction compared to what it was in northern latitude. Northern latitude, celestial equator is like this. In southern latitude, the celestial equator is inclined like this. What does that mean? This only means for you to just imagine, if you are standing on the earth at the equator, just imagine for a while, you are standing on the earth on the equator looking northwards. If you are looking northwards standing on the equator, right at the point of infinity is going to be your North Pole, celestial North Pole. Okay, what you see in front of you is what is the clear sky is available these days, because of, I mentioned to you, very clear sky these days. I hope some of you have gone and had a look at the super pink moon, which took place a couple of days back on Tuesday, Wednesday. The moon was so bright when it was rising, and you could see the stars. In fact, what you see here is your Big Dipper, which can be seen even from Chennai. If you are in northern latitudes, you can see still more clear. This pointer is the one which points toward the Polaris. You can even see the pole star. So clear is the sky these days. These stars are moving around in a circular path, always around the pole. Why? We saw all heavenly bodies move in a circular path around the pole. So this Polaris, as it starts moving around, this pointer will be always pointing towards the Polaris. You can see initially it was here. After 2 hours, this is the position. Still it is pointing towards the pole star. After 6 hours, the pointer is still pointing towards the pole star. You can see this portion in Chennai and northern latitudes even tomorrow, day after, till at least for 2 months you'll be able to see it. Please take a look, and the sky is so beautiful, especially after about 8 o'clock and 9 o'clock in the night. You can see all the stars very nicely available, right? So what have we seen so far? So far, we have seen the Earth coordinates are latitude and longitude, celestial coordinates are declination and right ascension, and horizon coordinates are altitude and azimuth. Your celestial navigation involves only this and nothing else. If I am able to relate altitude and azimuth, which I can measure from sextant and azimuth circle, and calculate the declination and SHA using the nautical tables, I can get the latitude and longitude, which is my ship's position. Or if I know the ship's position DR, from that, knowing the position of the heavenly bodies, declination and SHA, I can identify what is that star by looking at the tables and look at that object at that specific altitude and azimuth. So that's all your celestial navigation involves. It's just a correlation of these three. Some formulas are there, which we'll see later, which correlates latitude, longitude, the declination, SHA, and altitude and azimuth. Simple as that is your problems of celestial navigation.